In this video, I'm going to explain what sampling variability is, some important concepts and terms that you'll need to know in order to kind of describe what a sampling variance is going to be. And then also, I'll show you an online application that can help make this concept come to life. So, in the previous lessons, we talked about this process of sampling. And to keep it simple, sampling is when you want to gain information about a very large group, a very large population, and instead of getting information from every single person in that population, because that would take way too much time and sometimes take too much money, we instead gather a sample that is representative of that population. So I always like to start with a visual here. If this is our population, right, everything in green, okay, I might choose a representative sample that maybe is this small, okay, in red, where the red is my sample, and again, the green is my population. Now, what I'm going to do over here is just create a chart that outlines certain terms that you're going to need to know. And the terms that relate to a sample, I'm going to list in red, and the terms that relate to a population, I'm going to list in green, just so we can keep ourselves straight here. So let's start with the sample first, okay? And the name of this course again is statistics, and the statistic is based off of a sample. All right, so anytime you hear that word statistic, I'm thinking of information that's gathered from a very small group. Okay, the flip side to that, for we'll say the population side of things, is a parameter. So a parameter is any measure that relates to the larger population. Okay, oftentimes I call the parameter, I think of it like a unicorn. And the reason I think of it like a unicorn is it's very hard to obtain the parameter for any variable. Even if we conduct a census, for example, the median income of people in the US, that's a unicorn. We're never going to get that number exact. So we attempt to get to that unicorn, that parameter, by gathering a statistic. Okay, so both a statistic and a parameter can come in the form of any variable, whether it's we just use the example of salary, so it could be dollars, it could be euros, it could be pounds, it could be fluid ounces, it could also be percentages or the probability of something occurring. So I like to think of it as if it's something like a dollar value or pounds or something concrete like that, we call that a mean. And if it's something dealing with a percentage, I either say it's a percentage or a probability. Okay, so for a sample mean, and I'm just going to put in parentheses here, we'll say hours of sleep a night. And that's actually the variable we're going to study in a minute here. The reason that's a sample mean, or we refer to it as a mean, is because we measured how much sleep we get per night, not in percentage, but in hours, minutes, and seconds. We would label this with X with a little bar over top of it. Okay, and simple enough, we would say this is X bar. That's how we read that. Okay. Now, the flip side to this would be a population mean. Population mean. Okay, the same variable will exist, hours of sleep per night, but now instead of expressing it in terms of X bar, we use this Greek symbol, the letter mu, and we read it just like that, mu. All right, those are my quotations there. All right, so again, population is in green, samples in red. So those are measures of the mean. Let's say we had, let me just continue this, calm down so we keep ourselves situated here. Say we wanted to talk about a proportion or a probability or a percentage. We could say a sample percentage. Okay, and let's say percentage of U.S. citizens who register as independent. Okay, that would be a measure where obviously we want to measure that in terms of a percentage, and it's less practical or less useful to measure that variable in terms of a hard count. Say it's 100,000 people. It's more meaningful to say maybe 5% or 10% of the population is registered as independent. Okay, the symbol we use for a sample percentage is a lowercase p with a little caret symbol on top of it, and we read that as p hat. Okay. Now, the only difference between the sample percentage and a population percentage is you remove that hat. So we'll say population percentage or probability. You're still going to see this symbol, but it's just going to not have the hat. So p hat versus p. The p means it's population. P hat means it's sample. Okay. Now, in terms of, let's talk about this term variability. Like, what does that mean? To vary, it means that we're going to change. Right? In this case, we're going to change from sample to sample. And we use a couple measures to describe variability. I'm just actually going to go back up to the top here. And I'm just going to circle this term variability. And a couple of, again, measures that can be used for variability that we want to look at are first the size of the sample. All right. And sometimes that can be described with a lowercase n. So the size of the sample is going to dictate the variability or the results of the samples. If the sample size is larger, then results are going to be less variable because you're gathering more information from a more representative group of the population. It's going to be more consistent. You're also going to look at something called standard deviation. And later in this course, we'll show you a calculation for standard deviation. Same thing with variance. That's another measure of variability. And variance is the same thing as standard deviation squared. They hold that relationship. So if you had the variance and you want to work backwards to get standard deviation, you would just take the square root. Okay, and the last thing we're going to talk about is something called a margin of error. And think of margin of error as a shorthand estimate. I'm just going to write an estimate of standard deviation. Okay, and with all of these measures here, standard deviation, variance, and margin of error, everything we drew in black here, except for sample size here, but for these three, typically the larger the number, the more varied your data is, okay, or the higher the variance is. The lower the number, the less varied your data is, or the less varied your samples are, and the lower your variance is. So I'm just going to put down here, higher equals more variance. And then lower equals less variance. All right. So again, those are some of the terms in play here that we're going to use in our explanation. And the more you understand, the better and easier it's going to be. Okay, so let's go back up to our visual here. Just a graphic way to explain sampling variability. Say here's our first sample. What sampling variability says is that, and again, this is my population. my first sample is right here, and I'm going to label that number 1. Okay, sampling variability means that as I gain more and more samples, every sample is going to be a little bit different, right? And I'm just drawing these locations arbitrarily, but you can see how they're kind of spaced out. Maybe I get one over here. Okay, notice how they're all different, right? They're all in different locations. They're different part of that population. Yet we're saying that they do represent the population, okay? The key is we want to try and have the differences between samples as consistent as possible. Okay, the easiest way to do that is to increase the sample size. Okay, so let's say my first, I'm just going to go back and erase these. Let's say my very first sample was a little bit bigger. Okay, let's say it looks something like this now. Okay, logic would tell me that my sampling variability, instead of being all spread out, excuse me, like before, it might look something more like this, where you even have some overlap, right? Maybe your fourth one is somewhere in here. Do the fifth one over here. Okay, if you can kind of follow this. Notice how much smaller that variability has become. My circles are bigger. That represents a larger sample size. Okay. Now, let's take a look at an app. This is called the Rossmann-Chance Applet Collection. We'll be using that quite a bit throughout our course, and I do think it's a good way to help understand, especially this topic of sampling variability. Okay, so you'll see over here, and again, the website for this is rossmannchance.com/applets. We're going to use the one sample applet here, and there's a list of different variables here on the right. You have population 1, population 2, 3, Gettysburg, pennies, change. We're going to look at population 1, and we're going to look at the variable of sleep. In fact, that's the only option we can look at. Okay, we're going to quickly scroll through this table over here to the left, and think of this as if there were 18,000 people in this country. Let's just call this country Z, okay? And in country Z, there's 18,000 people. That's the entire population. Now, we had the time, the resource, the energy. We had all, we could figure out the average amount of sleep each person in this country is getting, all 18,000 people in this very tiny country. And we figured out exactly how many hours of sleep each person is getting, okay? And we labeled each person in the country labels number 1 all the way down to 18,000, okay? And they're in no order, okay? Well, they're in order by their ID number, but you can see how everybody's getting different amounts of sleep. Here's one who got 4.5 hours of sleep. Here's an 8 hour, okay? Here's 7.5, all right? But when it's all said and done, this is how the data falls out, all right, or lines up, right? These 18,000 people would take on, and this is called a histogram here. This is just a visual to show you how the variable of sleep plays out for that entire population, okay? So you can see most of the people here are getting 8 hours of sleep, okay? And that's evidenced here by the mean, all right? 8.001 hours per sleep per night. The standard deviation, again, the higher that number, the more variable the data is. In this case, it's 1.5, all right? I would need to do another histogram. Like, you need a baseline to see, is that variable or not? As of right now, it's the only standard deviation I have. So that's a difficult question to answer. And then last but not least, our population size of 18,000, right, or lowercase n. Now, let's take a look at the histogram itself and break down each axis. So your sleep axis over here goes from 0 all the way up to, this would be 14, all right? But everybody in my population looks like they're between 2 hours of sleep per night and say around 13 hours of sleep per night, with the mean having the highest peak, all right? And then notice your y-axis over here, that's your frequency. That's how many people are in each category, okay? So in other words, this category right here, that might represent everybody in country Z who's getting, say, between, we'll say between 5.5 hours of sleep per night and 6 hours of sleep per night. Okay, and there's roughly, say, 700 people, maybe 800 people who are getting anywhere in that range amount of sleep. Okay, and then your highest peak obviously is around 8, and it looks like about 2,000 people are getting that much sleep. Okay, now let's say we took a sample from this population. Okay, so let's say in an ideal world like we have here in Country Z, we interviewed every single person. We got their average sleep per night, and we documented that. But let's say we didn't have the time, excuse me, to do all that, and we only had the time to collect a sample and then use that to represent the population. Okay, so that's what we're going to do over here. We're going to show sampling options, and let's just say we drew one sample and the sample size was 10. So we're randomly going to select 10 people out of 18,000. We'll click on Draw Samples, and this lists actually all the different people the 10 different people that we selected, okay, and their average of sleep per night. And then you're going to see a couple visuals down here. The first one lists out every single person by a dot, right, and the amount of hours of sleep they got per night. If I count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Mean is 7.57, and the standard deviation is 1.65. Okay. So even in just a sample of 10, you can see it's fairly representative. It's off by a little bit, but the mean lines up pretty nicely. Now, what sampling variability is, the next time I click this button, how much that next sample is going to change from the first one. That's sampling variability in a nutshell. So let's do one more. All right, see how we pick totally different people. All right, but you could have the same people as the first sample. You could have some overlap there. But let's see what we get in this one. Okay, in this one we got 8.125. So now we overestimate the population parameter, but we're still pretty close. Standard deviation of 1.68. All right, and you can see how these ID numbers, or these members of the population, lay out. Okay, now one visual I didn't show you the first time is this next one, okay, over here to the right. And this is a way to show you how variable your sample is, what that sampling variability really is. So right now it's just the difference between, looks like a 7.55 and an 8.125. All right, but if we continue this, let's do one more. And for this one, I'm just going to jump right down to this visual. All right, the last one we got in blue here was 8.1. Didn't change that much. We'll do one more. And one right at 8. Okay, so between these 4 samples, you've had one that lines up pretty much directly right on the mean, one that's less than, and 2 that's above. All right, this process, that again, it's all sampling variability. All right, what I'm going to do here now is click on, instead of one sample, we're going to generate 1,000 samples of size 10. All right, I'm just going to draw them. We're going to see what comes up. Okay. All right, so here's your distribution. Okay, the mean of those samples is 7.983. All right, pretty darn close to our 8 hours of sleep per night. But notice how the standard deviation, notice how that becomes much smaller. The reason for that is you're looking at the spread of sample means, right? And it gets a little bit more consistent. We'll talk about why that decreases in just a minute here, okay? But here's what I want you to keep in mind, okay? We're going to look at this standard deviation, and if we choose sample sizes now of, we'll say size 100, all right, this should decrease, all right? This should go down because remember, the higher the sample size, the less variability we have, okay? So let's do that. Let's hit the reset button here. Everything goes back to 0. And let's say our sample size now is 100 instead of 10. I'm going to click on Draw Samples. And it's going to take a little bit of time. Okay, and again, notice how my data here is more consistent. My standard deviation goes down immensely. My mean gets even more accurate, almost at 8 exactly. Now, in this histogram, it takes on pretty much the same shape, right? It's normal. But what do you notice about the axis? right? We're going from 7.5 to 7.8 to 8.1 to 8.4. All right. Keep that in the back of your mind because we've already seen now the difference, standard deviations going down. I'm going to do this model one more time, and I'm going to increase the sample size from 100 now to 1,000. What you're going to see is not only does that standard deviation go down, I want you to pay particular attention to this x-axis, right? And what you're going to find is that these intervals are going to shrink. It's going to become even more and more consistent, okay? So right now our width is about 0.3, right? 0.3 hours of sleep per night. It's going to go down even more. All right, so let's go back up here. Sample size of 1,000. Now we're generating 1,000 samples of sample size 1,000. This process would take forever. It's the beauty of this application. It does it in a split second. Well, maybe more than a split second, but let's give it some time here and see what comes up. We'll wait. Maybe it's going to take a little bit longer. Do 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 do. Let me click on reset here. All right, tell you what. Since this is taking a while to load, we had 100 before. We'll do 1,000 samples of, instead of 1,000, we'll say 300. We're just going to increase the sample size from 100 up to 300. We'll see if that speeds it up a little bit. Draw samples. All right, here we go. All right, and notice how the standard deviation over here goes down. Our mean pretty much stays the same, 8. Standard deviation goes down even more. And then let's pay particular attention to that x-axis. Yeah, look at this. See how it goes down? The width before was 0.3 hours of sleep a night. Now it's a tenth of an hour of sleep per night. So it's getting even more and more consistent where the entire thing is between 7.7 and 8.3. Okay, so moral of the story, the higher the sample size, the more consistent your variable is going to be, and the lower your sampling variance is going to be.